Honored to have the opportunity to speak to you today about the topic of difference between standard deviation and standard error of mean. This is a subject that holds great importance in the field of statistics. Why variability matter? The image shows two distribution plots with the same mean value of 1. Even with the same mean, the two datasets could represent very different distributions. In finance, for example, two investments might have the same expected return, mean, but one could be much riskier, higher standard deviation, than the other. What is standard deviation? Standard deviation is a measure of the amount of variation or dispersion in a set of values. The image shows two distribution plots with different standard deviations, 1.0 and 0.5. The plot with a higher standard deviation, 1.0, has a wider spread of the data points around the mean, indicating more variation in the data. It quantifies how much individual data points differ from the mean of the data set. Standard deviation provides a way to understand the spread or dispersion of a dataset. A higher standard deviation means the data points are more spread out from the mean, while a lower standard deviation indicates the data points are clustered more closely around the mean.
The image illustrates the concept of standard deviation and how it represents the amount of data scatter around the mean value. The image shows a series of stick figures representing different data points. The distance between each data point and the mean value is shown, indicating the degree of scatter or variation around the central tendency. The larger the distance between the data points and the mean, the higher the standard deviation. This is visually represented by the taller stick figures being further away from the mean. Conversely, the shorter stick figures closer to the mean indicate a lower standard deviation, where the data points are more tightly clustered around the central value. The distribution plot in the image illustrates this concept visually. The plot on the left shows a normal distribution with a standard deviation of 1, while the plot on the right shows a normal distribution with a standard deviation of 0.5. The wider spread of the data points in the left plot corresponds to the higher standard deviation, while the tighter clustering around the mean in the right plot corresponds to the lower standard deviation. The image illustrates the concept of the standard error of the mean, which is a measure of how precisely the sample mean estimates the population mean. The population is the totality of items. A descriptive measure of the population is called a parameter. Sample is a subset of the population or portion of the whole and, if properly taken, is representative of the whole. A descriptive measure of a sample is called a statistic. If a researcher gathers data from a sample and uses the statistics generated to reach conclusions about the population from which the sample was taken, the statistics are inferential statistics. The data gathered from the sample are used to infer something about a larger group. The formula for standard error of the mean is equal to the ratio of the standard deviation to the root of sample size. The key differences between standard deviation and standard error of the mean. Standard deviation measures the variability within a single sample or population. Standard error of mean measures the variability between sample means that you would obtain if you took multiple samples from the same population.
For standard deviation, divide the sum of squared differences from the mean by the total number of data points, then take the square root. The formula for standard error of the mean is equal to the ratio of the standard deviation to the root of sample size. In terms of usage, standard deviation is used to measure the dispersion of a dataset relative to its mean. On the other hand, standard error of mean is used to determine how precisely the mean of the sample estimates the population mean. In terms of interpretation, a low standard deviation indicates the data points are clustered closely around the mean, while a high standard deviation indicates the data points are spread out over a wide range of values. A smaller standard error of mean indicates the sample mean is likely close to the population mean, while a larger standard error of mean suggests more uncertainty in this approximation. The key difference between these two measures lies in their applications. Standard deviation is concerned with the variability within a single sample or population, while standard error focuses on the variability between different samples drawn from the same population. In essence, standard deviation tells us about the spread of individual data points, whereas standard error informs us about the accuracy of our estimate of the population mean based on a sample.